Moving a bug around the screen is not terribly exciting
This video is brought to you by OppiePie's Academy.
until you know that that bug is being moved with the accelerometer. As I tilt left, the bug moves left. As I tilt right, the bug moves right. If I tilt up, the bug moves up. And of course, any combination of those. So I'm actually using the accelerometer now to interact with an object on the screen. So the accelerometer extensively becomes an input device. Let's stop that and stop the awful 8-bit sound that we're playing along with it. All right, so let's take a look at the code to do this. We already know how to read the accelerometer. So here we've added just a couple of dimensions to make that more interesting. We've got our phone gap template here, and our UI is actually really, really simple. If we come down here to the body, we have our canvas. Now, a canvas is a drawing surface, if you haven't used it before, that you can render with HTML5. And that's actually what you physically see the bug on. The whole gray area here on my phone represents the canvas. Below the canvas, we have the accelerometer div, same as we had before in the last demo when we were simply reading the accelerometer. So really nothing new in the UI except that canvas element, which gives us that nice, easy drawing surface on which we can move our bug graphic around. On the accelerometer div for styling, we went with 6M, 0.6M, so 60% of normal size. For the canvas object, we went with a background color of gray, CCC, and I set a margin at the top of 30 pixels. This way it didn't interfere with the information that's part of the iOS operating system, my signal strength, time, and other indicators right here. This HTML body overflow hidden, because I stretched the canvas across the entire screen, it was recommended that we go ahead and set the overflow to hidden for HTML and body. I'm not sure that's really having an effect, but better safe than sorry. So what's left is our actual JavaScript, and I've added a number of additional global variables. The context, which I'll explain in a moment. Position X and position Y, which will track the X and Y coordinates of the bug as it moves through the screen. We have an object here, the image object, and that's to track the actual bug image. And then on line 47, audio, which is, of course, our audio object. So this works basically the same way with some additions. The onload function is run, and we wait for the device ready event. And you'll remember that that's a phone gap specific event that runs when the screen is drawn and basically everything is ready to go within the device itself. We call the onDeviceReady function when the device ready event occurs. Third argument's false, but it's not relevant in this case. So on device ready, once the device is ready, first we're going to set up the canvas. We had a canvas element in our HTML, but we also need to size that element. So what we're going to do here is we're going to get the canvas element. We ID'd it as my canvas. And then we set something called the context. We actually draw on the canvas context, and you can get a 2D context or a 3D context. Obviously, for this, we only needed a 2D context. Now, we're going to set the size of the canvas by setting the size of the context. So we're going to get the context canvas width and make that the size of the window, and then the context canvas height, and we're going to make that the size of the window minus 150 pixels. And what that's giving us is the room for this content down here at the bottom, which shows our accelerometer readout and has our two buttons. We're going to initially position the bug in the center when we first run the program. So we need to we need to find the center of our canvas, and this math does that. We take the width of the window, divide it by 2, and subtract 25, which is half the width of the bug. On the y-axis, the up and down axis, window inner height divided by 2, half the height, minus 175, which accounts for half the width of the bug, or half the height of the bug, I should say, and that space where we have the accelerometer readout information. Now, this next section may be a little curious to you, and the reason we have it is to prevent what's called a race condition. So to load the bug on line 65, we create a new image object. That's basically an object that holds an image, but there's nothing in it yet. And then we create an onload function for the image. And we say once that image is loaded, once that onload function runs, then on the context, we're going to draw the image, and the image, of course, is this image object, at the position X and position Y, which right now is the center of the screen. Now, the reason we have to do this way and then actually source it as bug.png on line 70 is we don't know how long it's going to take this graphic to load. And if we try and draw it with the code on line 67 before the actual graphic loads, we're going to have a problem. We're going to have a race condition in that it hasn't loaded yet and we're trying to draw it, so we're going to have a problem. We're not going to get the actual expected result. We load the bug on line 70. You might have heard some awful 8-bit audio in the background. So on line 73, we're loading that audio. And it's just called blip.mp3. We load it as an audio object. So we have the audio variable, a new audio object. This is called instantiation when we create a new object. And the file, blip.mp3. Now, in order to get it to loop on the audio, we add an event listener, and when the audio has ended, we run this anonymous function, which sets the audio playhead back to the beginning, and we play it again. So essentially, we're just looping the audio and playing it over and over and over again. And then to start it the first time, we need this line 78 audio.play. So the start watch actually starts our accelerometer. The start watch function, we have our options. This time the frequency is going to be 100, so 10 times a second, 100 milliseconds. We're going to check the accelerometer. We're going to then use the watch acceleration method and have our on success, on error callbacks, and we're going to give it our options, which is just the frequency. So navigator.accelerometer.watch acceleration starts the accelerometer. We have our on success and on error callbacks, and that's attached to a watch ID. That just carries the ID of this particular accelerometer watch so we can stop it later. And when we start the watch, we start playing the audio. Now, the stopwatch, we go ahead and check our watch ID. And we clear the watch, we set the watch ID back to null to get ready for the next time, we pause the audio, and we set the playhead back to the beginning. And you may be wondering, why do we play the audio on 85 and 78? Well, 78's for the first time we start, but on 85, anytime someone clicks the button, we also need an audio play to restart the sound when the actual button is clicked. All right, so now here's the heart of this. This is the on success. This runs each time we get a reading from the accelerometer. So 10 times a minute, or every 100 milliseconds, we're going to get this to run. So first we want to change position X. We want to change position X along the X-axis. So we're going to change it by whatever amount the accelerometer is reading. So the more the accelerometer reads, the more the actual tilt of the device, the faster the bug will move. So we're simply using this. Now, this is reversed. So in order to get it to move to the right when it's tilted right, or to the left when it's tilted to the left, we have to actually multiply it by -1 to reverse the sign. So if it's negative, we make it positive. If it's positive, we make it negative. And this way it moves in the correct direction. We then have our positive Y. We just simply add the acceleration for Y to position Y to move it along the Y-axis. And again, positive or negative to move it up and down using this. Then we clear the canvas. So the way you actually animate in HTML5 canvas is you clear the canvas. So context, clear rectangle. from 0, 0 to the width and height. So we're giving it XY coordinates. That clears the entire canvas. We redraw the image. There's our image objects, but after we've updated position X and position Y. So we update the position, we clear the canvas, we draw the image again. It gives the illusion of movement. And then just like before, we output the acceleration information. If we have an error from the accelerometer, we simply alert that we have an error. And there you go. We've got a now interesting little program that without a whole lot of code or effort allows us to move our ladybug around the screen with the accelerometer.